What other set of Freire models? Huh? Statistical and non-statistical questions, okay? So guys, y'all should have those 2 sets of Freire models done. I need to remind you, or I need to remind you. Am I going to be checking those?
Yes. Oh, no, maybe.
The Freire models are the white pages that have the main idea in the center and has practice problems on there. So what you have right there, Rihanna, those are the Freire models. So quantitative versus categorical and statistical versus non-statistical. So remember, am I going to check those? No. Why not? Why am I not checking those? Because there your notes. What else? They're for you to get better understanding. Yeah, what's on the backside of it? The answers. Guys, I've already given you the answers so that when you do them, Ivan, you can check right away and say, ah, I got it right. Or, you know what, I might need to ask a question. So remember, when on the bell ringer, it says, write any questions you have on the unit. You can write down, hey, Mr. Kenny, I have a question about, which is this, the updated one? Yeah. I have a question about the mild section of categorical versus quantitative, right? The idea is that you can ask those questions at the bell ringer so I can answer them before we move forward. I'm not going to check your understanding questions. How am I going to assess if you have mastered that skill? When?
You asking us questions and stuff like that up there?
So one, when I ask questions, like you should be able to know those answers, right? So the sooner you do those practice problems on check your understanding, the better the quicker you know if you understand it or not. When else am I going to check though to see if you understand?
On that little paper thing.
That I will mark stuff off there when you take this thing.
I'm trying to think of the name.
So I have a special name for it. Not other teachers don't call it this. Most teachers.
Check our understanding.
So to check your understanding is the Freire models.
Well, what does it start with?
Huh? The assessments, right? And so like remember, most teachers call them a quiz. I don't call them a quiz. You are going to check your own understanding, and then my assessment is going to be called a demonstrate your understanding. We haven't had one yet, but you need to check your understanding before I assess it on a demonstrate your understanding. So do the practice problems. If you do the practice problems and you're rocking and rolling, you're probably good to go. If you screw up, then you need to ask questions. So I don't want these homework assignments to be a grade. One, if I do it for an accuracy grade, then that puts pressure on you to get it right rather than letting it be a learning context. Plus, I want to give you the solution so that you can check yourself right away. I don't want to check it for a participation thing because I've seen students do this when I taught at Tuscaloosa Academy for a couple years, which was 2 of my worst teaching years ever. It was rough. But when I taught there for a couple years, I had another teacher, the football coach, come into my classroom and teach. And I literally, at the class change, watched kids write down random bull crap so that they could have answers when he checked to see if they attempted the homework. Like, they just wrote down random crap. And you and I both know, like, you're going like, but you and I both know people do it, right? Like, you just write down stuff. I don't want you to write down stuff. I want you to think through. To check your understanding, the homework, the practice is for you to help make sure you understand, okay? So I want it to be a self-assessment for you, for your practice. And I can tell you this, the students who do the check your understanding for their learning's sake do better in my class than the students who don't. Because the students who don't usually fall under one of 2 contexts. Either one, they're just really, really smart and so they can skate by without doing any work. Or 2, they're not really smart and then they struggle. Which is not to say they're dumb, they're just not, like you and I both know, there's people who are like next level and they don't have to practice at all and it's very frustrating, right? There's those people, but most of us aren't those people. And so if you're not doing the practice, you don't actually know if you understand it or not. Because when people get to the quiz or the demonstrate understanding in the test and they're like, Mr. Kinney, I thought I knew it. Well, did you practice it? Well, no. Then how did you think you knew it? You didn't check. Okay, so make sure you're doing that practice. From there, I didn't mean to do syllabus reminder. I haven't checked today. I checked yesterday to see if some more people turned stuff in and sent out a message to parents who I hadn't gotten information from. So if your parent hadn't submitted a syllabus, would they not let you drop yourself off?
My fourth block teacher was, he tried to go to my third block, he wasn't there either.
Gotcha. So syllabus reminder. All right, today we are going to quickly recap statistical questions versus non-statistical. We're going to quickly recap data types, and then we're going to get into random sampling, and I should have actually included types of bias. What unit are we doing today? Same unit we've been on. We're still on what? So that's a skill within what unit though? What unit are we studying? Unit 1 is all about statistics. We're still on study design, okay? So we're still on study design, we're still on statistics. We are for the most part going to finish up the section under observational studies. We'll get to experiments early next week, which probably means we'll have a demonstrate your understanding either Monday or Tuesday associated with observational studies. So I am going to point out on the proficiency scale soon, which again, I would always have my proficiency scale out on my desk so I can refer to it. But the proficiency scale, I'll identify what we're talking about. You got the yellow sheets, but you want 1A. Unit 1A, that's the observational study stuff. All right. And so, I just completely forgot to update on the agenda. I added the right slides, forgot the agenda. Quick question, because I need y'all to know this. We all need to know this. Statistical questions. What is the key to having a statistical question?
It has the variability to have different answers.
So variability is possible in the responses, right? So answers or responses. Responses is usually what we use in statistics because answers implies it is what is correct, right? But it's not necessarily right or wrong when it comes to statistics. It's just what the response is. So if I were to ask about the favorite sport for Hillcrest High School students, would that be statistical or non-statistical?
Statistical.
Statistical, right? Are different students going to have different favorite sports? Yes, okay? But Jaden, if I were to ask you, what sport is being played next Friday? Like what sport does Hillcrest High School have next Friday? Is that statistical or non-statistical? Why do you think it's statistical, Jaden? But you were saying non-statistical. Why were you going to say non-statistical, Rihanna?
I only know about football. Like all the tennis and other stuff, I don't be studying. So I only know about football.
Okay, so you only know about football.
Everybody
So you're also saying there's only one response.
Only one thing playing on Friday. That's football.
Right.
Football season stuff.
But I don't think they play Friday.
No, it's-
Actually, could say
it's
Friday
just
night.
football.
Regardless, though, you said there's only one response, right? Hey guys, if there's only one response possible, is that statistical or non-statistical?
Non-statistical.
That's non-statistical. You good with that now? Okay. So make sure we consider that. Remember, non-statistical is when there's only one response possible. Like over here, who was the first president? Who is the first president? I hope we know this. George Washington. Is there any other response?
No.
No, right? So non-statistical. Okay, so what made data categorical? What made data categorical? Or a variable categorical? So this is the next set, guys. This is what we ended with yesterday. We gotta know this.
Categorical quantitative.
Yeah. But what made something categorical versus what made it quantitative?
Categorical was like in like categories and like
Okay.
stuff like that, and quantitative was like numbers like different like.
Okay, so what about cell phone numbers? Would that be categorical or let's say cell phone area or just phone area codes?
It's categorical.
Okay, is that categorical or quantitative?
Categorical.
Okay, but that's a number, isn't it?
Yeah, but it's just because like
It's in the group.
yeah.
But it's in a group. It is not a what? Starts with a Q.
Quality.
It's not a quantity. Like to be a quantity, I think Rihanna, you were saying earlier, to be a quantity, That number is a result from doing one of two things. What?
Being counted and measured.
Being counted or measured. Is the response from counting or is the response from measuring? Now remember, there's always, with categorical, going to be some kind of counting. The question is the response a category or is the response a quantity? The way I mean that is this. If I were to ask how many siblings students in this class have, right? So Finney, how many siblings do you have? 6. That response is a quantity. That response came from a counting of siblings, right? But if I were to ask who prefers football to basketball, so raise your hand if you prefer football to basketball. Keep your hand up so I can actually count, okay? So 1, 2, 3, 4, 5, 6, 7, 8. Notice how I had to count there? So there's counting involved in categorical variables. However, what was the response? That person prefers football. So remember, it's about the response. There's always going to be some kind of counting with categorical variables. But is the response a category or is the response a quantity? You had a question? There's tissues back there. All right, that's our recap. So that is everything in the foundation. Hey guys, what happens at the end of the year? And so I want you to focus on the learning side of things, but I also want I want to be clear about how the grading will work. Remember, your proficiency scales are 50% of your overall grade. A foundation right here, if you can do those 4 things, or you know these 4 terms, and you can do these 2 things, all of them, then you have gotten to the foundation level of the proficiency scale. Okay? And so that would be important. By the way, if I have my proficiency scales, I would think through, especially if you've already done the practice, did you correctly do the practice with these things? Then you can confidently mark it off for yourself. If you haven't done the practice yet, you don't really know yet. So I would do some practice to make sure that you can say, hey, I can do this skill. All right? But I'm going to come back to that in a second. Right here, this is where we're really getting into, so identifying the sample, the population characteristic of interest. By the way, you have a Frere model for that as well. Let's say you can do all of these things. Okay? Let's say you can identify if a study is a survey, observational study, or an experiment, identify sources of bias, and explain the importance of randomization. And let's say you can do all of these things, okay? That's pretty good if you can do everything in the target, right? I need y'all to pay attention to this. And if you have a target, that's a 3.0. But let's say you can do all of those things, but you have not figured out quantitative versus categorical yet, you're still only at a 1.5. Let me say that one more time. Let's say you hit all the target stuff, everything in the 3.0, but you are missing something in foundation, you're at a 1.5. Okay? But if you get all of the foundation and just one of the target, you're at a 2.5. Okay? And this is important on the grading side of things. Again, I want you to focus on the skills. Like, this is what you need to focus on, these skills. But on the grading side of things, I'm going to average all of your proficiency scales at the end of the course, and that is going to end up determining 50% of your grade. So what do you need to make sure you definitely have everything every single time?
Your proficiency scale.
Yeah, but like which part like has to be you have like mastered? Guys, remember, if you get all of the target, but you're missing some of the foundation, what are you automatically going to be dropped to? 1.5. So what do you got to make sure you have? The foundations. Guys, you got to know that stuff. And I don't want that to happen to you, because I have had students who crushed on the target and missed some of the foundation, so they're stuck at a 1.5. Make sure you have the foundation, on top of the fact that the foundation is kind of important for what you're trying to get to. You build on the foundation to get to the target. So make sure you're getting that foundation. Make sure you do those practice problems. Now, I think we already did this yesterday in this class, right? Okay, so we can move past it. I do want to point out, do you have the Frere model? No. Yes, you do. I do want to point out, under categorical versus quantitative, when it says spicy, mathematic lesson 1, check your understanding number 1, that is referring to this question right here. So this is a really good practice, spicier practice, to make sure you're ready to identify variables on a test. And if you have categorical or quantitative data. I would do my mild, I would do my medium, and then I would finish with this. Please note, am I asking you to do number 2? No, because is that tying in at all to categorical or quantitative? No. Okay, so I'm not asking you to do that number 2, just the number 1. I'm trying to be intentional with these things. Any questions that you have before we continue? Looks like a no. Looks like some of us are ready for me to move on so that you can get up out of desk and actually do something and not just listen. But guys, I'm trying to establish foundations. Again, I do want to point out, the bell ringer, like I know that some people are scared to ask a question in the whole class, like to talk up, or speak up, but the bell ringer is a great time for you to write whatever you need to on the board to ask that question. You can write it on any board. I don't care where you write it, as long as it's clear that you have that question, right? So if you want to erase the whiteboards, or if you want to erase the chalkboard, write your question up anywhere that you have it. All right. What we're about to get into is explaining the importance of randomization in surveys and observational study. This is foundational to everything we're going to be doing for the rest of this unit. And within that, we're going to practice identifying the sample, the population, and the characteristic of interest. All right? And then later today, I think we should be getting to bias. Okay. Oh, and these different types of sample down here we're going to get into. So we're going to talk about these different types of sampling. All right, so there is, I don't know if you're aware of this, but has anyone ever heard, and I'm going to tie it into this in a second, has anyone ever heard that some people suspect Shakespeare of not actually writing all of the plays that he produced? You've heard that before? They say it's a little sus. Do you want to know one of the ways that they determined that they don't think he wrote all of them?
What is that?
What I was about to say. So one, there's evidence like some of the plays, like where the ideas may have come from ideas that were before, and those ideas were lost from older people, like older generations, and he kind of just rewrote them or took them as they were. But also, when you write, as a whole, you use roughly the same number of letters per word throughout all of your writing. What that means is, like, traditionally, if you use bigger words, what are you going to always do? Use bigger words, right? If you usually use smaller words, typically you're going to use smaller words, right? And so I bring all that up to then say, like, that is one of those things that has been 100% shown time and time again to be true. J.K. Rowling, what did she write? Harry Potter, right? Really big deal. And then after Harry Potter, she wanted to take a break, and I don't remember what she wrote, but she wrote some book under a pseudonym, some other name, and people actually realized, hey, this is actually J.K. Rowling. How did they figure it out? They analyzed the number of letters per word in the book. Because this author came out of nowhere, and they're like, this sounds weird, like, who is this author? It was a really big deal. And then they realized, hey, we think this is J.K. Rowling, and it turned out it was because of the length per word. And so here we have Beyonce, okay? What we're about to do is look to just see, and we're going to tie this into a second lesson later, but we're just going to look at Crazy in Love, we're going to analyze it, and we are going to try to figure out what we think the average number of letters per word is for Crazy in Love. And as I said, it's going to come back up as a second lesson a little bit later, so let me pass out these materials for today. Okay?
What made you think crazy?
So what I actually used to do is I used to let students pick their own song, and I had like 10 different songs, and like the class would pick. But this is just really well designed, so I did this instead. What actually happened was Mathematic used to do the Gettysburg Address, but you know what high school students just don't care about? The Gettysburg Address. And so I actually had the idea of, hey, let's analyze song lyrics. And then they stole my idea. Not literally, I think we just independently came up with it. But song lyrics are way more fun to analyze than the Gettysburg Address. At least I would think so. Do you agree with that, Walter? Yeah? Okay. And I assume, slash hope, everyone has at least heard the song Crazy in Love.
Is it Drunk in Love? You just take drunk out?
Nope.
I never heard Crazy in Love.
Seriously, we've never heard Crazy in Love before? Y'all kidding, right?
No, you do know.
Okay.
No, I don't.
All right, well, I guess I need to educate you. We know who Beyonce is, though, right? Why are you having to whisper it,
Isn't that
Jess?
Jay-Z's wife? Hey, Jay-Z, what? What is that?
Yes, Jay-Z. You know her as Jay-Z's wife? You don't know Beyonce as just Beyonce?
Yeah.
Okay. All right, let's do this. For kicks and giggles, I'm gonna play the video really quickly. I will have to stop the camera because I've done it in the past and then YouTube will be like, oh, there's copyright infringement. Right, so I'm gonna pause it while we watch the video, or than some of y'all, which really hurts to feel and hear. What's up, Dean?
How does the letters for words work if there's a feature in the song? One of Jay-Z's-
Yeah, so I will point out, if you look at the lyrics, are his lyrics in there?
No.
No. So if you look at the lyrics, so we should have the Crazy in Love thing out right now. And there's a reason why we don't have his lyrics in there. I'll explain it in the next part of this lesson, okay? So all we're going to do is we're going to look at the words that she wrote, and we're going to look at, hey, what do we think the average word length is for this song? All right? So, what was I looking for? Yeah, so quickly circle a random sample of 5 words. Write those 5 words below, so number 1. And then how many letters are in each word. And then what is the average word length of your sample. So what I would point out is, can I see this real quick?
You said how many?
What does it say on the sheet?
5.
5. So what you would do is just take this, okay? Now remember, we're trying to find, and I do want to point this out, we're trying to find, so pause for a second. We're trying to find what is the actual average word length of this song, right? How many letters per word are there? Does that make sense?
296.
No, there's 297 words. So my point is this. Do you want to go through all 297 words to find out how long the average word length is? No, Brianna was like, that sounds terrible, right? Because that would take forever, wouldn't it? So what are we doing? So, by the way, what do we call this thing? What do we call all the words for this?
Your sample.
All the words, that's my population. Remember, what do I mean by population, Vinny?
All the individuals.
All the individuals that I want to know about, right? So then, what is my sample? By the way, guys, you're going to have to do this on assessment, so I need you paying attention and locking in. I need you practicing these things. So what's going to be our sample here?
The 5 words.
So the 5 words, notice the words are my individuals, the 5 words selected, that's my sample. And what's the last thing? Population, sample, and characteristic of interest. What are we interested in here?
The letters.
What about the letters? All the letters? Amount of letters? I don't know about amount of letters.
The average number.
The average number of letters per word. Average number of letters per word, okay? That's my characteristic of interest. So again, trying to practice these things, identify what's going on. If you need this as a reminder, that might be a good thing to write down here. So characteristic of interest, okay? So I'll give you a second to write that down. But I do want to point this out, just so we're all on the same page, because I don't want this to hold anyone back. How am I, let's just say I picked the 5 words, looking. All right, I've got look, by the way, circle, for this first set, circle on the front side over here, right? So I'm going to give this back to whoever this is. Abby, this is yours. I'll be back in a second, okay? So I've got the words looking, I've got crazy, that catches my eye, I've got doing, so I'm just picking 5 random words, I've got pride, and I saw the word understand earlier. Okay, so I think that these 5 words might give me the actual average. Because here's the thing, do I want to look at all 297? No. By the way, don't take my 5 words. You need your own 5 words. These are the 5 that caught my eye. So it says 1, 2, 3, 4, 5, 6, 7 letters. Crazy has 5 letters. Doing has 5 letters. Pride has 5 letters. And 10 letters. Okay, so how am I going to find the average number of letters per word now? Not the most. So the most frequent is called the what? The most frequent is called the, it starts with an M. It starts with an M. It's called the the one that shows up the most frequently is called the mode, okay? Mode. But I'm looking for the average. Oh, by the way, I should ask this. Oh, do we have a categorical or quantitative variable here? Why do you think categorical?
That's what I'm saying.
I don't think it's categorical because we didn't like pick, like we say your favorite anything was looking and you have other people agreeing with you. I feel like that was categorical.
Well, but like I wouldn't say.
So we just count like.
But what is categorical?
It's a group.
It fits into a group. What is quantitative?
Count.
And by the way, when we say it's a group, the response fits into a group, right? But quantitative, the response is a measurement or counting. It's a quantity from measuring or counting. Aren't I looking at the number of letters?
Yes.
How did I get that number of letters?
Count.
I counted. So is that quantitative or categorical? Quantitative. A small hint, I want to point this out. You cannot average categorical data. You can only average quantitative data. You can only average quantitative data. Okay, but my question, because this is what I really want us to focus on, how am I going to calculate that average?
Add the numbers divided by 5.
Okay, so you add up all the numbers we have, and then, why are we divided by 5?
Because there's
5
5
words.
different numbers.
5 different numbers, or 5 words in this case, right? So we add up all of our values, so sum of values, and then we have how many values we have, right? So regardless, I'm about to put my average up here. I need you to do your own average, and then we're going to make a dot plot in a second. So I'm going to put a dot plot up here that you can build on, but I need you to pick the 5 words that you think best represent the population. Individually. Each one of you is going to do it. If you need help, then talk with your group. I will point out there are calculators in the back that I would highly recommend using, and get used to using those because they're going to be way easier for you long term in this class. So I would go grab a TI Inspire. You will actually need one later today because the other calculators can't do what I'm going to show you on the Inspires. Yes?
But you want a black right back here, or we don't need that?
This,
Yeah.
I would write it on the front. The back side is going to be the learning target. So this is practicing old stuff. The back side, the learning targets go there for what we want to learn out of this lesson. Okay? All right, sorry, Abby, there's yours. Okay.
So I add my look, divide by 5.
Right. Hey guys, can y'all please come grab calculators as I already suggested? I promise you, it's worth it. And so I want to point this out, just looking up here. And so John, let me know what you get when you finish, okay? So we're going to do a couple more rounds of this to try to get the most precise or most accurate look. Now, here's the thing, and I need y'all to pay attention to this. So, Dean, hold on and look at this, because this is going to be foundational to what we do in a second. Why did everybody get a different value?
Because we pick different words.
Because we picked different words, okay? We had different samples. Remember when we did the Curious Case of Joy Milne, did everybody get the same number of correct guesses with the shirts?
No.
No. That's because of something called sampling variability, okay? So, getting away from blue. Okay, sampling variability is just this. Sampling variability. Different samples different samples will produce different results. It doesn't matter how you sample, different samples will produce different results. There's variability in there. So if we had just looked at one data point, this data point, what would we think the average number of letters per word is?
2.5.
2.5-ish, right? Okay. But if I look just at this data point, how long do I think the average word length is? 7.1, probably a 7.2. So remember, it went by it was by 0.2s. Okay. But if I look at all of this data, I need eyes and ears here, guys. This is important. Jess, over here. Okay. If I just look at one data point, that doesn't give me a ton of information because of what? Different samples produce different responses, results, which is called sampling variability. So one data point doesn't give me a ton of information. But if I look at all of our data points together, what do you think the average word length of Crazy in Love is?
5 and 6.
So 5 or 6, I mean, it's pretty clustered around here. So let's try to come up with a single value. So 5 point, how are you deciding, by the way, between 5 and 6?
Just the more is on 5.
The what?
The most
The most,
responses.
so the mode is somewhere between 5 and 6? Okay. What else could we say? Why would it make sense? I'm just going to estimate here. Why would it make sense to say the actual average is right here? Because it's more up there. There's another reason, because there's actually more right here. Why am I saying here? What is this in respect to the data set?
That one has the most responses.
Not right here, it doesn't. This one does.
6 is like the actual.
Well, 6 has the most responses, but I'm saying like right here, just to the left of 6.
Like just around?
Like,
There's a
You
C
kinda
word.
divide it in the middle.
It's dividing in the middle, so it is in the...
The middle.
They are close.
This is roughly the center. It's roughly in the middle, right? So like that's roughly the center of the data set. So just coming out with a single value, based on all of our data collected, I might think 5.8 letters per word, right? A little bit closer to 6 than it is to 5. Does that make sense? Okay. But what I want us to do is I need you to be aware there's more than one type of sampling method out there. What I want you to do now is I want you to pick any line, random line. Let's make this rule. Don't pick the first line because then everyone picks the first line. Pick any line. Use the first 5 words to find the average number of letters per word. So pick a line. Just do the first 5 words in that line. Okay? Find the average number of letters per word. Okay? So pick a line, write your 5 words down. I have to find how many letters there are. Yeah, pick any line on there. So Ivan, on the other side, buddy.
This?
Nope, the other side.
I'm on this side.
Yeah, that side. Okay. Pick a line, any random line. Take the first 5 words and find the average. Put that dot plot, by the way. So guys, we're going to do another dot plot. Put your dots here on this axis, okay? Yeah, so there's not space for this. This is where I'm changing it from mathematics. Are you talking about putting it on the graph? Don't put it on the graph yet. Just follow my directions on picking a line, using the first 5 words to find the average number of letters per word. You already done with it, Dean? Okay, go ahead and put your data up there. If you want to get another line, you can do that. Okay? You good? I got you. Come on, just pick 5. Trust me, pick 5. Or pick a line. Find the first 5 words in that line, okay? Okay. 10. Wait. The last one was 4.4?
No.
Which one is this though? Is that the new one? Okay, so go put that 4.4 up there and then put that 3 on the bottom axis, okay? Okay? And so again, if you finish early, help us get some more data, okay? This second dot plot is based on you just picking a line and getting the first 5 words. Now, did we all get the same data?
No.
No, we did not, right? And if I just went off at this data point, I would think that the average number of letters per word is 6.2, 6.4, somewhere in there, right? All right, so that'd be pretty high. But if I went off at this data point, I'm thinking 4.6 or so. So why did we get so many different responses?
Because it was different stuff.
Because there were different samples. There's another word, there's two word thing I'm looking for. Different samples, so there was.
Different variability.
So
Responses.
we're still up there, dog. Sampling variability. Thank you, Chelsea.
I said very good.
I know, but different samples producing different results is sampling variability. We've got to know that term. We're going to add it to the sheet later, okay? But based on this data set, how many letters per word do you think the song is?
4.5.
Yeah, I mean 4.5 would be right here.
Oh, 3.8.
3.8, so maybe here.
4.6.
Now I'll say this, if I'm looking at it, I will point this out. This looks to be the center without this data point, but if I include this data point, what's it gonna do to the center of that data set? It's gonna pull it to the right. And so what we are talking about is an average. Averages are heavily affected by what we call outliers. So even though the majority of my data is in this region, I think because of this point that's way over here, I'm gonna say that the center is somewhere around here, about 4.2. So about 4.2. This center was about 7 or 5.8. Now I'll point this out. Can both of those be correct for the true average number of letters per word? Guys, listen to my question again. The true number of average letters per word, that's for the population. I don't know what it is, but how many correct responses are there for the true number of letters per word? There's only one, right? Like there is some value that I don't know. So are both of those possible?
Yes.
Is it possible for the whole song to have 5.8 letters per word and 4.2 letters per word?
No.
Guys, there's only one value. So can it be both of those?
No.
No. Could it be that it's actually neither of those even?
Yes.
It's possible, okay? So let's do this. This time, we're going to use something called a random number generator, okay? So random number generator. So what I need you to do is I need you to pick up that TI Inspire because you can't do it with many other things. And I also need you to flip over the Crazy in Love lyrics. So create a calculator page on your Inspire and flip over Crazy in Love. And you'll notice that every single word there is labeled with a number. Right? What is the first identifier for one of those words? Number one. I is number one. And what is the last identifier? 297. And what word is that? Hey? Okay. Now, I can't remember if I said this before, but I need eyes and ears. And John, if you need to turn the desk so you can see more easily, just same thing. If you need to turn those desks so you can see more easily, like not just turn in it, but you can actually turn the desk if you need to. But I think I've said this before. What's the button that lets me do cool crap on these calculators?
Enter.
Control.
Okay, so I haven't said this in this
Dude,
class.
take it off.
Say again? Menu. Hey guys, if you don't hear anything else, actually I hope you hear lots of these things because statistics is important. The button that lets me do cool crap on these calculators is menu. Alright, does anyone see an option up here that might make me think about random selection?
The number?
So statistics, number would make sense. No.
Probability.
What? I will point out what's right next to probability.
Dice.
A die, and die are pretty what? Random. So probability is where you actually do want to go. Notice under probability, what do we see?
Random.
Oh, there is literally random in here.
It ain't give me a random number.
Okay, so go to random. Now don't do anything else, because here's what I need you to understand. Do not, because it's very tempting, do not use random number. Random number just does a string of decimals between 0 and 1. That's not what we want. Okay? What kind of numbers are 1, 2, 3, 4, 5, 6, 7, 8, etc. to 297? Huh? Those are integers. So guys, these numbers that are on here are random. We want random integers, okay? So follow along with me really quickly. Random integer. All right, so once you get to here, so we should have, so make sure you hit number 2. By the way, don't forget, you can actually hit the number 2, not just like click on that thing. Like if you use the numbers on the calculator, it makes things easier. Everybody this page? Coriana, you there? Annalise, you good? Jess, you good? Brianna? Okay, I'll take that as everyone's good, and you get a whole lot of reaction. But, all right, so what you have to do in random integer is you have to put the lowest identifier, a comma, and then the highest identifier. So what was our lowest identifier?
1 and
1
297.
and 297. Now, does anyone know where the comma is on this calculator?
At the bottom.
At the very bottom left. If you find the pi symbol on the keyboard, it is just below the pi symbol. So you put a comma there, and then what was the highest identifier? 297. Okay. So hit enter. Okay. So this should be a random number, right? Anybody else get 281 though?
I got one.
Wait, you got what? 281. You got 281. Hey, raise your hand really quickly if you got 281.
We got 140.
Hey guys, there's 297 words here. A whole bunch of us got 281. That doesn't feel very random, does it?
Nope.
Okay, so do this for me. The reason why that happens is because calculators are still computers. They still have a program. They need a seeding element. They need to know somewhere to start. Okay, by the way, let's try to make sure we don't, I know some people have already done it, so let's try not to draw on the calculators anyway. They still are nice pieces of technology I got to take care of. All right, so what's the button lets me do cool crap? Menu. So go to menu. Then we're going to go to probability, and then random.
No, image.
Remember what I just said was it needs a what element to get it started? Nope, that's what we want to, it needs a random seed, right? So the seeding is what gets it started at random different places, okay? So I'm going to go to random seed, and then you're just going to type in any old number, okay? One common one you can use is like your birthday, like I could put 0318-1991. No one else has that birthday in this classroom. But you can type in any random set of numbers, and that's going to tell the calculator where to start. I hit enter, and now you can do, so like once you put your birthday in, you put a random number in, now you can do random integer. Now, don't go past the screen. Stay right here for a second, because I want y'all to see something. Okay?
Mine say too few arguments.
Now I gotta restart.
Hold on. I can't believe I forgot to record all of that. What's up?
Messed me up. Now I gotta restart.
No, you don't. Okay, it's fine. Menu, calculator. I'll come and check on you just 1 second. But just do the random seed. That's all you need right now, okay? So, Coriana, menu, dog, probability, number 5. For random, do a random seed, okay? Just type in any random numbers, hit enter. Okay, once it says done, you're good. All right, here's what I need y'all to see quickly though. Right, eyes and ears here. One of my favorite features of the TI Inspire is simply this. Now, could you go back to menu and probability and random and type all that stuff in again? It's easy enough. But here's what you can also do. You can hit the up arrow, and you see how it highlights that stuff in blue? I'm going to go all the way up to random integer so that it's highlighted in blue. And it has to be highlighted in blue, but then I just hit enter, and it brings it down so that I can re-enter it. So go up until that random integer is highlighted in blue, hit enter, and it'll bring it down. And you can hit enter. Did anybody else get 188 this time?
I got 2 of some.
I got 170.
But my question is, did anybody get 188?
No.
30. But my point is, are we getting the same numbers this time, or is it truly random? It's truly random, okay? So we're getting random things. So here's the thing, based on what number you get, that's what you're going to select. Now, I got 188, so I'm going to use the word no. Okay, so 188 is going to be the word no. I need to do this 5 times to get 5 words. That's fine. It's any random. Remember, my point is, it should be random. We shouldn't have the same numbers.
So I just keep clicking it.
So keep clicking it until you get 5 random numbers. Use those to help you select the words on here. If you are stuck, use your group mates to help until I come over and help, or until I can get to you. You're going to have to let me see it again, Victoria. Mr. Caleb.
Hold up, but it's a whole class, not just you.
Alright, look. Right here. I want us to pay attention to this. Based on our new data, well, first things first, why did we not all get the same data? Why did we not all get the same mean? Because there's what, Finney? There is sampling variability. Guys, I can't emphasize that enough. Why do we get different responses? Because of sampling variability. So, one sample is not always the best. Sometimes we need multiple samples to get a true picture of what's going on. Based on this new sample, what do we think the true average number of letters per word is? Maybe 4? I will say, like, yeah, I was thinking maybe closer to 3.8 here, because there's a chunk of data points like right here. So I'm not saying very different, but 3.8 might be what I'm thinking, all right? So let's say the center is about 3.8. All right. So here's what I want to point out. You ready to find out what the true average number of letters per word for all 297 words is?
Yes.
Okay? So the true average is 3.53 letters per word. So, in this data set, were we even close? No. I'm going to talk about why in a second, right? Now, I will point out, were there some data points here that were close? Yes, okay, but not most of them. In fact, most of them, or the center was way higher than the true average. In this data set, right, we were a little bit closer, but was it really centered around the true average? No. In this data set, it's not perfect, but was the center closer?
Yes.
Why do you think this center was closer than the other two options, sampling methods?
Good, random.
But like, didn't you pick random words before?
Yeah, but like,
So let me ask you this, was the words you picked earlier truly random?
no.
No. You picked them, right?
Yeah.
Now I want you to hear me on this. When you pick, that's called a subjective sample. Alright? A subjective sample is when the researcher picks the individuals in the sample, okay? So, you picked them. Why in the world did y'all pick way too big of words?
To even it out.
Not to even it out. Like, why did you pick too big of words? Any guesses?
I think 4-letter words.
So you thought mostly 4-letter words, but like, as a whole we didn't. Guys, I need y'all to think about this. There's a logical reason why you picked way too big of words. What's the reason? Huh? Yeah, well, but like, there's not that many larger words because the true average is 3.5 letters per word. So why did we pick such big words?
They look longer.
I know, but why did you pick them?
Because like, it was like, you know, like, I don't know.
Let me ask you this. What catches your eye? A big word?
A big word.
Or a little word?
Big word.
A big word, right? So, big words were catching your eye because they're easier to see, and so our data was way off. Now, in this one, were our eyes picked by big words necessarily, or drawn by big words?
Not necessarily.
Not necessarily, but I want to point this out. Was it pretty easy to just pick 5 words in a row?
No. Well, not like when we had to look like, oh, on this paper right here.
Yeah, when you just looked at a line, you picked 5 in a row.
No, it wasn't that easy. Like, I was looking around.
It was easy. It was easy.
I will say this. I'll ask you this way. Was picking a row and just getting 5 words in that row
that was
the easiest of these 3?
Yes.
Yes, so it was easy, right? A word that we use for easy is
convenience.
There was convenience, right? There's convenience stores. Why do convenience stores exist? Because they make your life easy, right? They're easy to access. You don't have to go all the way to a grocery store. They're easy access. So this is a convenience sample. So what do we mean by convenience sample? This is what for the researcher?
This is
Convenient, which is
easy.
easy for researchers. But, listen, did these accurately represent the population?
Yes.
Remember,
Well,
this
no,
center
not,
was
not,
way
no,
too high.
Yeah, not that one.
This center was a little too high, right?
Mhm.
But still high. So did these accurately represent the population?
No, they didn't.
No. And I'm running out of room up here, so I'm going to write it off to the side, and I'll figure out a way to add it to maybe fourth blocks. But I need you to hear me on this. I'm going to erase this information right here. But let me actually end here. Well, no. All right. These samples, or these sampling methods, are biased. When you've heard the word bias before, what does that mean?
I just had Mr. Cole, It's like when you showing favoritism.
It's when you're showing favoritism. And there's still some element of that idea here, but I do want to point out that the term bias has a very specific definition in statistics. It ties into this idea of showing preference. Which words were your eyes drawn to? In the top one, the big ones, right? So in that subjective sample, your eyes were biased towards the big ones. In here, it's not as clear on that, but it's still biased. It was just what was easy for the researchers. When we say the sampling methods are biased, what we mean is this. The samples will consistently yield poor estimates of the population. Let me emphasize this. In the biased methods up here, did all the samples miss the population values? Or get really far from the population values?
No.
No? There were a couple data points here, right? Okay. In this one, there was quite a few data points around here, right? But in these, the sampling method resulted in consistently poor estimates. Here, did we perfectly hit the population average? We didn't do it perfectly, so keep that in mind, Fanny, but we did it perfectly. In fact, several data points are outside, right? Pretty far outside. But why are there...
Excuse me, this interruption. Teachers, don't forget to let your students vote for HCA officer elections before the end of second. Thank you.
So, what I need us to understand and pay attention to on this one is when there's going to be variability, for what reason? Because different samples yield different responses or results. That's the sampling variability. There's going to be sampling variability. But does the center match? In this case,
No,
did we consistently have poor estimates, or were our estimates pretty good?
no, we didn't have decent.
I mean, they're pretty decent. They have about the same center as the true average, right? So is this data set, or is this sampling method biased?
Yes. No.
Is that pretty close to the true average?
Yes.
Yes. So was it biased?
Yes. No.
No.
I said
Biased means poor estimates.
No. I said no the first time.
Okay. So what was different about this sampling method? Someone already brought it up. This sampling method was? But why? No, this one wasn't easy. This is probably the most
No, the
complicated
easy
method.
one is at the top.
Yeah,
No, but the middle.
Guys, what did you do here?
Random, it was random.
It was what?
Random.
Thank you. Random
No group.
sampling
Simple.
Attention.
reduces
I pledge allegiance
reduces what?
of the United States.
Any guesses?
And to the republic for which it stands,
Yeah, but what do we call the thing when there are poor estimates? Oh, so it's reducing what?
Bias.
Bias. Oh.
Nice one.
Oh, guys, all that work was for you to understand this.
Did you have on the board, on the class?
Yeah, maybe. Because I might have talked about it right here when I did it with my stats kids. Right? Oh, calculators don't have eyeballs. Random number generators reduce bias. Oh. These are not principles that are unique to y'all. I need y'all to understand. I think y'all get out of here at 11:30. Is that right?
Yes, sir.
So here's what I need us to do. We need this information, okay? I'm going to check to see if I'm missing anything. But okay. That shouldn't say 4.1. Y'all's is a little bit different. Should say 4.2. All right. So guys, under the quick notes here, what are some of the big ideas that you need to have written down here in the next 6 to 7 minutes? Sampling variability, you need to know about that. Okay, so I'm going to have 3 different learning targets. Sampling variability. You need to have that info down. I will point this out. Hey guys, right here. I know they're doing announcements. I need y'all here. Let's pretend like this is my entire set of all individuals. What is that going to be called?
Population.
That's all my individuals, so this is my population. Now, there's a few different ways we can get a sample. You could choose. Researchers choose. What is it when the researchers choose?
Yes. No, that's a
Bias.
It is biased, but it is a
Subtraction problem.
yeah, subjective
subjective sample. But what's the problem with a subjective sample?
It's biased.
It's biased, meaning it does not represent the. What does not represent? Well, the population. Okay, that's biased. You could have a convenience sample, which means it is what for the researchers? It's easy, right? But that's going to be biased. Listen, if you're doing a survey with people, you could ask for volunteers. We can't do that with this one. But if you ask for a volunteer sample, any guesses what that's going to be? If it's going to be biased or unbiased? If you're asking for volunteers, that's going to be biased. What do you have to have for it to be unbiased? You got to have a random
response. Number. Sample.
Thank you. This is the only thing that can reduce bias. Random samples reduce bias. Notice I didn't say it gets rid of. Are some of these data points off?
Yes.
Yes, why are some of these data points off?
We all got different sampling variability.
So sampling variability. Guys, you'll still have 4 minutes, so no one should be packing up yet. I need you to have these notes down about the different types of samples. You need sampling variability, and you also need to write down these definitions for the different types of samples. You need that information. And you also need to write down what bias is. Like, everything here needs to be written down. You've got to have that info. It is important. I hear people moving stuff around that does not sound like writing notes down.
When they say commercial, how many?
Convenient.
Convenience, yes. Don't use it. I was saying, you trust yourself to remember.
Sampling, I'm running with a
Wait, what?
sample.
Mr. Kenny, when you say right, what other sample and variability?
The definition that I have over here. I would probably also put bias underneath that as well. So like, because sampling variability exists, and that is different from bias. What does bias indicate? That the sampling methods are consistently yielding poor estimates, right?
You're insane, John.
Sampling variability always exists. Contrast that with bias. Sampling variability versus bias.
You're insane, John. How did you do that? John, you're insane.
It was insane, you.
Just people, they got it.
I am not going to bring in an excuse for your
Actually,
You probably should do that ASAP. Because if you miss a day of school, then that absence, if it's unexcused, it counts as a 0 on the active collaboration.
I'm not getting wrong, so trade out.
Teachers and all staff members, as it becomes your lunchtime, there is a barbecue plate in the downstairs teacher workroom for each of the employees. Thank you.
I'm not getting a real.
All right, Jay,
I think he gave it